Well, in answer to the question, am I an entrepreneur? Yeah, I'm addicted. It's a drug I can't get away from. So Delta T Enterprises, we're a 35-year-old company. Right now we're a group of 16 engineers and a small manufacturing thing in electronics and light assembly. And through the years we've done 10 to 15 product design projects a year on one of two bases, either a straight cost per job or as a partner in that we take a piece of the action.
So this is forward. Okay, natural laser.
So what I thought I could talk about today is what product development is. There's 3 key activities that are involved. It's a very broad topic and we're only going to skip across the top. And more important, how these have to work together. And then I'm going to give you an example that we're hot and heavy in right now in the agriculture world. So if we're going to talk about product development, we need to talk about what a product is. And this is my favorite definition. It's a manufactured good that closely meets the requirements of a market and yields enough profits to justify its existence. If you don't have all 3 of those, it just isn't going to work. So in short, it's an idea that has been converted into a profitable reality. Hence our tagline, ideas to reality. So the 3 key areas are the technology, and it starts generally at the beginning with a new product, and it processes through engineering and design and pre-production. Markets also start at the beginning. You don't do the one and then go find a market for it. And you don't have a market come and find the technology. If the 2 can work together to merge, that's your best bet. And then of course manufacturing starts after you've got something to build, and it's vital to your profits. But they don't work independently. So a little more detail, a little more graphic here. Technology involves research, design, development, prototyping, testing, defining how the manufacturing may go together, that kind of thing. Marketing, again, research. What does the market want? What will they pay for it? How do we get it to them? Marketing is telling your story so that people know you've got what they need. Channels, how do you get it to them? Do they want to go to their local drugstore and buy it, or are they going to buy it over the web? And of course, sales. Quite often your channels may do your sales for you. So how do they work together? Well, in the beginning, market research and technology research merge to produce 2 documents. One is a requirements document, which is an overview of what the product has to do to meet the market requirements. And the second is the design specification, whereby the engineers and the market people work together to pare down what can be done, what the costs are going to be, and what manufacturing targets have to be met both in cost and volumes. Manufacturing, it's all about quality. And quality is all about processes. They have to be responsible for warranty. And they're the ones that ship. So how do these work together? Well, the technology and the manufacturing start pairing together when you get into your pre-production, your first small run, be it a 10,000 run or a 2 run. The engineers know how they think it should be built, manufacturers know how they want to build it, and you change the design and you change the manufacturing processes so that you optimize that. How does the manufacturing and marketing work together? Well, it's the distribution is the link. Basically, the marketing is forecasting how many they're going to need in the future, and distribution is placing orders on the company. Manufacturing is shipping through distribution, being it in-house or third party. In our case, usually third party because we're not big enough. And so if you put it all together, you get a little trifecta of circles, and the thing that makes the whole thing work is money. Now, in the beginning, it's research dollars that you've raised substantial government help, those kinds of things. But ultimately, it's the profits of the product have to generate enough so you can do this over and over again. Because products, especially in our world, they don't last that long, and you have to add more bells and whistles and make them cheaper and whatever. So the example I want to give is one that we're very heavily involved in right now. It's a company called myfarm.ag Management Inc. It's an Alberta company. We started it 2 years ago after a year of research in another company, so it's a kind of a spin-out. Delta T owned half in the very beginning, and our marketing partners owned the other half. We've since diluted, of course, by raising money. We've spent about $800K in R&D to date. We first raised $400,000 from a large agribusiness, a public company, and I got to say, we, as best we can, we try and raise the first and even the second round of money from the industry. Because you go ask a farmer, do you think this is a good idea? They're going to tell you it's a good idea because they don't want to hurt your feelings, or maybe it is a good idea. You go ask somebody to dig in his jeans for 400 grand and tell you whether it's a good idea. If he does, it's a good idea. At least that's our belief. So roughly a year ago, we did our first installation in a fairly large farm down off of just outside Claire's home. And we did a full product launch at Farm Tech Conference in Edmonton in January. We had a 20-foot booth there. We had a live thing. Since then, we've raised another $500K from farmers just in the last month or so. And while I was at lunch, I just got the email, the contract from Ag Canada for $750,000 assistance to go forward is in the mail, finally. So what is it? Well, your farm at your fingertips is the tagline. This is supposed to have motion in it, but it doesn't. So there's a need in farms to monitor various aspects of stored grain. Right now, there are several large companies providing online, continuous, up-to-date monitoring of everything that goes on in wheels. Once it comes off the wheels, it's pieces of paper, and I've talked to more farmers that think they've actually had their grain stolen, but aren't too sure. That's how close some of the record keeping is. The other thing is the grain can rot, it can heat, you can get insects in it. All that storage aspect needs to be controlled and measured and recorded, and ultimately our plan is to be able to track the wheat or canola or whatever from the bin to the end processing plant. As a gentleman from Maple Leaf pointed out, this is important. This guy gets good stuff, this guy doesn't. You get whatever shows up at the door. Again, this didn't work out right, but so the problem is on-farm storage needs to be monitored. Damp grain reduces its value and it can rot. Insect activity impacts the stored grain. What is the quality, what is the grade, protein content, sugar content, these kinds of things in the future we need to know. So what we did is we developed some low-cost temperature sensors that hang in the bins and give you a temperature profile in the bins. That's not new. I actually developed a similar thing back in '87. There's a support cable because when the grain comes out, there's about 3,000 pounds of pull on that cable, and it's got to be strong enough to take it. We developed, again, a low-cost level sensor. How much grain have you got? They don't really know. We got fluke lucky, and we've just discovered that using that level sensor, we can also get the average moisture content of the grain, and that's a holy grail. That was luck, not skill. We have humidity sensors, CO2 sensors. We can control the fans. We have weather stations and automatic alarms, and it's all web-based. So how does it work? Basically, on the top of each bin is a small radio unit that is taking all of the measurements. It passes it to what we call a coordinator, and the coordinator then sends it out via a cell phone to a website that's basically graphical based. You can put in alarms if the rate of rise of temperature goes up by so much. If your grain suddenly starts disappearing, you can send the cops, all this kind of stuff. What does it look like? This is our first production, pre-production. The router on the left goes on the top of the grain bin. It's solar powered, battery backed up for 20 days. It's just magnetic mount, and it connects up to the cables and the temperature sensors and the humidity sensors and anything on the roof. These things are what they call a mesh network, so this one can help send that one's data till it finally gets to the coordinator. You can see there's 2 antennas on the coordinator. The small one is a cell phone, and just the top part of the sensor cable is there. These are some of the companies that we've had discussions with. After we closed the last round of financing, one of them, I can't say who because of NDAs, came roaring in the table. We had the CFO and the CEO of one of Canada's largest manufacturing companies. They want in a big way. So, money. R&D costs were assisted by NRC IRAP and of course SREDs. We've minimized overhead until now. It's been next to nothing. Best money comes from industry. We raise it in stages to limit your dilution as best we can. Thank you again to Agriculture Canada for their great support. And we have a line of bank leasing and whatnot, because the business model is like your cell phone. The farmer pays per month and he gets the equipment for free. So what are we going to do next? Well, we're busy building the first 300 cables. That's our pre-production run. We're starting production of 3,000 cables for the spring of 13. And we're in discussions with a large agribusiness. And we have a project underway to start the first part of tracking the quality of the grain off through the farm until it's shipped in their trucks. And of course, the object of this exercise is to exit and become rich.
Thank you very much, Gary. Really, that was a wonderful lesson. You nearly answered the question of how the technology meets the company. Okay, we've got time for a quick question from somebody.
Care to elaborate on how you're using your level sensor to read moisture content?
In a very minor way. It's still proprietary, but our level sensor actually measures the total quantity of water in the bin. And we correlate that to the grain level. And we found another way to get an accurate grain level at certain instances. And so we have 2 equations, 2 unknowns. We can calculate the total amount of water in the bin. We know how much grain is in. Average moisture content is a given at that point.